So hopefully you all got some food, drinks there, did what you gotta do and all that. I'm refreshed and ready to give a big warm welcome to first time speaker, Yasmine. Give it up, folks.
Everyone. Do I turn this on? It's on. It's on. Okay. Hi everyone. I'm very excited to be here. This is my first talk, my first big talk. I'm going to be talking a little bit about the use of machine learning in healthcare and diagnostics. So, predictive patient outcomes. So, introduction to myself. My name is Yasmine. I'm a new founder of a startup that is still in stealth mode. I want to give a little bit of a shout out to tech founders. So I'm very grateful to these type of communities that encourage women to get into tech. This is an organization that's been set up by a woman called Miriam Murray, and it runs mostly in Ireland, in Dublin, where I come from today, and we do some work there in Belfast as well. So a big thanks to these to Techmaker and Tech Founder, two great organizations. So as well as talking about machine learning in healthcare, I want to talk a little bit about my journey going from engineering into AI-powered healthcare. So my background is in engineering. I studied design engineering, specializing in process optimization, a little bit very similar to product development, to product design. I went on to complete a PhD, really committed myself to engineering there in materials science, where I developed coding methods and specialized in advanced manufacturing. And then went on to work in medtech. So things that I did in the work that I did in medtech was mostly mechanical design, so designing implants, looking at the processes, improving the workflows, and ensuring that they're cost efficient, process efficient. So things like knee arthroplasty, spine implants, all of those good things. And then more recently, I decided to take a little bit of a detour and change trajectory. I started to upskill in machine learning, AI, and finance. I've had a thing for finance. So I found like a middle meeting area there afterwards for what I wanted to do going forward, and that's a new challenge for myself through going into a startup. So they're hard work, but I'm quite new to that. I found this intersection between AI, machine learning, and patient care. Yeah, so a little bit of this nice little intersection. There's vast amounts of data being produced in healthcare, and the data that particularly interests me is unstructured data. So it's data that's being underutilized, that we could gain critical insights from. And these insights often are, hidden in plain sight. We can make more sense of these things. There's been a lot of advancements in the use of AI in healthcare. I'll talk a little bit about some case studies and some research which has inspired me in the products that we're building out. I think the use of AI and machine learning in healthcare has the potential to really transform the diagnostics field. So my mission statement, I went in with a core mission statement that I could, my North Star, which I could always revert to. I wanted to improve patient outcomes and clinical decision making by transforming medical data into actionable insights. In that, I wanted to hone in on one area where I could transform data into useful information that could help GPs and medical professionals make better decisions. So some problem areas here that piqued my interest into getting into this. So electronic records, this is coming in from an Ireland perspective. So we have a couple of stories in the news about patients being unable to access their own medical records, having to go through slipped my mind. It's a process of retrieving information there. Instances where data is lost, miscommunicated, and these are really big challenges. Again, about the data point of view, it's not fully utilized. There's all this information that goes without being processed and underutilized. And communication, we want to create a more effective line of communication between healthcare providers and patients. So looking a little bit about the current research landscape. So one area that's really taken off in machine learning in healthcare is machine vision and the use of neural networks. So you'll find that a lot of the research has to do with interpretation of images, so of which you find plenty of in healthcare. So it's X-rays, MRIs, CT scans, classifications for dermatological lesions, and surgical assistance. And one thing this is great at is that these are areas that require specialist knowledge. So you'd think you could automate it and have a specific set of instructions, but there you need to have a little bit of some specialist knowledge there. So 3 areas that have really taken off: dermatology. So this is an easy one for them to solve. So it's checking out to see whether certain lesions are cancerous or benign, and that's using neural networks. Again, with radiology and CT scans, it's using the same thing, and then also using natural NPL to analyze health records. This is an area which I will go into a little bit more. So yeah, neural networks. That's something that you commonly come across when you're coming across these case studies. So essentially, you're turning an image into a binary value and then going through sort of hidden layers for computational transformation that helps them recognize complex patterns. So it's constantly feeding in new information, and it gets better with the more data that you feed into it. Some notable companies. So Google Health and DeepMind, they have a collaboration with retinal, with Moorfields Eye Hospital in the UK. So that's recognizing, they have a vast database of retinal scans and detecting also, I think it's kidney injuries as well. There's VizAI, and they just gained FDA clearance for analyzing CT scans. PathAI, then dermatology, that's been a really big one. They've been quite successful in that. So going back to startup, which area would we like to focus on? By we, it's a small team. I haven't mentioned here. So it's electronic health records. That's a really big one. There's a lot of information that goes unused, and having spoken to some GPs to see what the process flow is like, I've noted that longitudinal results, and that's the results that are spanning from a certain period to another, are not always used. It could be just you going in and it's just maybe they refer back to the last checkup as opposed to your entire health records or a certain time period. So there's information to be gathered also from medical imaging, which we went over. That's been a very popular one. Wearable devices. We had things like Apple Health kind of take off some time ago, Fitbits. And that's kind of died down a little bit. And then also we can gather information from social media. Also, that's something that's a little bit underutilized. We want to hear back what patients have to say. So how do we make use of big data here? A little bit of design thinking inspiration here is to simplify a big problem. So this is from Don Norman. The same technology that simplifies life by providing more functions in each device also complicates life by making a device harder to learn, harder to use, and this is the paradox of technology. So we're introducing all these complex processes, but we have to ensure that it's easy to use, easy to understand. So really honing in and focusing on one key area that is that we find most value to solve. In this respect, blood tests are an easy one. So with blood tests, you typically have information about your test results, and then you have a normal range, which is typically differs from males or females. So, and then an interpretation, so whether you're above a certain level or below level. And I think it's not too straightforward because you have to take in certain accommodations as well. Some people are naturally have elevated levels, and there's nothing wrong with that. So you have to be a little bit careful with that. But essentially, it's a quantitative data that is very easy to use in this regard, and is perfect fit for big data interpretation. So longitudinal health data, talked a little bit about this earlier. So we can get incredibly rich information and insights when we look at results spanning over a period of time, so 6 months instead of just the past test or one before that. So this gives us the opportunity to do early warning systems. We could personalize the baselines. So again, a level for one person may be normal or abnormal for another. And this allows us, again, to do preventative intervention. And a lot of people believe this as well, that the future of healthcare isn't just in treating disease, but in recognizing the earliest signs of when intervention is needed. I just want to talk to you a little bit about a machine learning process called random forest. And this is kind of inspired some of the early development of the prototype that we're still working on. So the random forest algorithm is a machine learning technique that is really great at inferring relationships from seemingly random information, unstructured information. It can find non-linear relationships as well, so it's not direct. You might not be able to find out through normal statistical methods. So another great thing about it is that it could do classifications as well. I'm just going back. It can do classifications. So we're able to, I'll go through the case studies soon, so you're able to kind of figure out which variables have the most impact or outcome on your, which predictor variables have the most income or have the most impact on your outcome. So I'm going to just present to you with a blood test case study. So this is to do with chronic kidney disease. So this is a highly preventable kind of disorder where the kidneys can't filter blood in the way that they should, and it affects, I think, 15% of people in the UK. There are risk factors here that you can predict that somebody might be more susceptible to contracting it or developing it, and that's diabetes and high blood pressure, etc. So some researchers looked into the use of random forest decision trees into predicting whether somebody might be susceptible to developing this disorder prior to early signs. So using longitudinal blood test trends, we try this out ourselves. It'll pick out the most important factors that impact the outcome. So in this instance, it's creatinine, EGFR, and phosphorus. And you can see they, when they're measured over a span of 6 months, these levels kind of vary. So with phosphorus, it tends to go in an upward trend, same with creatinine, and then a downward trend in the EGFR. So we're training, again, that's the Python code. There's just training the data set there on your own data and the collected data set. So you can see here, when we have a look at the risk probability, random forest can predict it 3 months earlier than classic or traditional statistical methods. So you'll be able to tell that somebody is at higher risk 3 months prior. It's more sensitive, it has higher accuracy than traditional methods. And this is really great. So I mentioned that the feature importance. This is something really neat about that machine learning technique, is that you can pick up the predictor variables in order of importance and how they impact the outcome. So we're able to see that these three elements there have a great impact there. And just how we envision this would work. I'll talk to you a little bit about the process workflow. The patient undergoes a routine blood test. The results are automatically analyzed by our system. The GP receives standard results with the machine learning insights, and then they're able to utilize that for decision making. So it's not a replacement for GPs. It's not a replacement for healthcare. It's just there as like a co-pilot. It's a co-pilot to assist healthcare providers and allow patients to also have a little bit of autonomy over their own data and to be in the loop as well. Some benefits. So early detection, that's really the big one there. Early detection, better communication between patient and healthcare providers. This reduces the cognitive load on physicians. There's you hear about overloading in the healthcare system there, and there's some challenges, obviously, with regulation. That's something that we'd have to look at. So, and some validation. Oh, and also integration with existing healthcare IT systems. That's quite a big one. So, to see how the compatibility works there. It's a call to action. I'm doing a little bit of research here. This is if you have any connections to GPs, you're interested in this topic, or you can help make a connection so that I could get some validation trials. Please do get in touch on LinkedIn or speak to me afterwards. It would be immensely helpful. I really like this quote. I would like to end on this quote. The best way to predict the future is to create it. Poignant, by Peter Drucker. It's a world-renowned management consultant. I think, I interpret it, I'm not going to say how I interpret it, but ending on that note. Thank you so much.